When an electric dipole is kept in external electric field, it experiences a torque. Suppose there is an electric field directed in a direction represented by these parallel lines. This is electric field. Now, an electric dipole is placed in this electric field having direction, having an angle theta with electric field. This is the direction of electric dipole moment of the dipole. Both the charges are equal. This is minus q charge and this is plus q charge. Now, because these two charges are kept in electric field, negative charge will experience a force in opposite direction to electric field, which is equal to QE, and same force will be experienced by positive charge in the same direction of electric field. As these are two equal and opposite forces, so net force on electric dipole is 0. But because these two forces are not in the same line, they will produce torque and they will try to rotate this dipole in the direction of electric field. Torque is represented by symbol tau, and it is force into perpendicular distance between both the forces. So like one force is in this direction and the other force is this, so perpendicular distance will be this perpendicular distance. If this is 2a, this perpendicular distance will be equal to 2a sine theta. So QE into 2a sine theta, Q into 2a E sine theta. This is electric dipole moment. So we can write torque is equal to P E sine theta, or we can write it cross product of dipole moment and electric field. Now this shows that torque is a vector quantity which is equal to P cross E. As this is a vector quantity, so it has a direction also, and direction is perpendicular to both dipole moment and electric field. Now, if angle between dipole moment and electric field is 0, that means dipole is placed in the direction of electric field. It's like this. Theta is 0 degree. In this case, torque on dipole will be 0. This is called its stable equilibrium position. If theta is 90, that means dipole is perpendicular to the electric field. Torque will be P into E. In this position, it experiences maximum torque. If theta is 180 degree means dipole is placed, that means its dipole moment is opposite to electric field. In this case also, torque will be like PE sine 180 degree. This is also 0. So this is also position of equilibrium, but this equilibrium will be unstable equilibrium. What is the difference between stable and unstable equilibrium? Stable equilibrium is that when dipole is placed in this manner, when dipole moment is along electric field. If you displace this dipole, like that means if it is placed like this, you displace it slightly like this and leave it, it will come back to the same position. This is called stable equilibrium. But here, if this dipole is placed like this, you displace it slightly, it will not come back to this position, it will rotate and go to the other position. That means once you leave it, it will go back to its stable equilibrium position.